Functions are the order of the day. I would ask you what you know about functions, but I don't want to. So, instead, I will tell you what is a graph. What is a picture of your favorite graph? What is it? What is a picture of your favorite graph? What equation? What geometric figure? A circle. X minus h squared plus y minus k squared equals r squared is a circle centered at hk with a distance of r. Okay? That's how fast you have to know things. That's a graph. It's a relationship of an equation. If I draw a vertical line through that, it hits the graph in 2 points. Therefore, you have 1x and you have 2 y values. That means it is not a function. You cannot have 2 y's for the same x if it's a function. A function is a higher step of a mathematical relationship. For instance, those not paying attention right now, you've missed the definition of a function. I can give you any equation right now, y equals x squared. Are there 2 y values for the same x if I put it in there? I don't know what you mean. I know, you weren't paying attention. Let's try this from the beginning. If I graph this out, y equals x squared. It's a parabola, it looks something like this. If I draw a vertical line, is there any place where it's going to hit the graph twice? You don't have to do that. You can just know. That's what the graph is doing. That's what the vertical line test is doing. It's telling you visually, are there 2 y's for the same x? In this case, the answer is no. So y equals x squared is a function. What's the variable in this? What's the variable you're using to graph this? Is it x or is it y? X. So you say, my rule I'm going to call is f. My variable is x. That notation tells me it's a function, and it's going to equal x squared. That's a function. If I ask you to make a table, you could go x, y, f of x. You can put in 0, get out 1. Y and f of x are the same because it's a function. That's what f of x means. It took me like a month to get past that. Nobody ever told me that when I took calculus for the first time. Nobody said f of x means y. But f of x tells you it's a function that passes the vertical line test. X equals y squared. What variable am I using right now to generate my graph, x's or y's? Y's. If y equals 1, x equals 1. If y equals negative 1, what does x equal? 1. I have 1 x value for 2 y values. Is that a function? No. Is it a graph? Yeah, absolutely it's a graph. It looks like this. So it can be a graph, but it doesn't have to be a function. A function strengthens things when you write them down. I can't write this as f of x equals anything. It's not a function. So this f of x is just a fancy way of saying y. But it also tells you that the graph passes the vertical line test. When you see that image, f of x, it tells you right up front that graph passes the vertical line test. What is the vertical line test? Only 1 y per x. You could have, look in this case, negative 1, you get 1, you get 1, 1, 1, 1. You see how y is used twice? That's okay, as long as you have different x values. That's fine. It's when you have 1x with 2 y's, that's not good. That doesn't pass the vertical line test. Right there is the problem. Functions have unique characteristics. In this one, does anybody know what type of diagram this is called? It's after a German mathematician. It has 4 letters. The first one's a V, the last one's the N. That's a Venn diagram. The reason the Venn diagram is so neat is a lot of people have problems reading it. This is telling you this is your domain. This is running through a rule. Generally, we call that an equation. And this is your y's, or this is your range. Notice, they're all using F notation. This tells you that the variable is W. This tells you the variable is Z. This tells you the variable is X. This tells you the variable is A. That's very important in calculus. Huge that you know what the variable is. So, it takes a rule, maps it. Do you see how we have an X here and an X here, and the same Y right here, the same Y value? Do you see how that works in the Venn diagram? Oh, watch very carefully. I like to ask this on a test or on a quiz. What if you drew a Venn diagram of something that was not a function? And these were your X's and these were your Y's. How would something look that wasn't a function on a Venn diagram? Yep. Yeah, it'd have two arrows, one from X, and the same one from X to two different Y's. I said the definition of a function. This is a Venn diagram of something that's not a function. One X to two Y's. On a graph, we used the vertical line test. That was on a graph. We used the vertical line test. On a Venn diagram, that means it's not a function. In calculus, we don't like to work a lot with things that aren't functions. We can, but we don't like to. We like to have things that are functions. So there it passed the vertical line test. What other tests are there? Do you remember? There's a vertical line test, so there must be a horizontal line test. That means it's a one-to-one function. A horizontal line test means 1x per 1y. No, two y's can be used. An example of a one-to-one function is a cubic. It passes both the vertical and the horizontal line test. It doesn't intersect the graph twice. One-to-one functions are great to work with. They have so many characteristics, you could study them for over a year and a half to 2 years. We won't be doing that. We'll briefly touch on them. But that's another type of a function, a one-to-one. So this is a function that's not one-to-one. A function that is not one-to-one. Okay? Your TI is set up to give you function values if you like. We'll get to those in a minute. This is great. I like functions. All right, any questions about the Venn diagram? Nice job, by the way. Any questions? Moving on. What does this say? For many cases, we can remember the domain is a set of X, also known as the mantissa, and the range is a set of Y's, also known as the ordinates. So, domain, range, also known as the independent. Independent. Oh, is that how you spell it? Independent? No, it's an E? 3 E's in a row? Wow. This is dependent. Again with the 3 E's? I think there's an A in there somewhere. No A's? Okay. Independent and dependent. X, Y. Domain, range. Nice. A graph is a function if it passes the vertical line test. Ready to move on? We've already talked about that. Oh, do you know what these values mean? Yeah. I get people that are so arrogant on these questions, they get them wrong. They have a how can I call this? A false sense of self-ability to calculate these. I say, they think they can do it in their head. And I say, that's great. But in calculus, a point's a point, and if you have a graphing calculator, I'll teach you how to use it. Yeah, you can do this in your head. You can put -3 in. You can put -3 in, but I always check it on the calculator if you have one sitting there. Not always, most of the time. So go ahead and get your calculators. There's a couple ways of doing this. Let's see, calculator, there you are. All right, so before we get going, f of x means that this is a function, correct? What's the name of the function? What's the name of the function? It's the first letter. F. So this is a rule known as the f function, okay? I'm going to type this into the calculator just to show you different ways of doing it so I can quit. You can do it the regular way. -3 is in place of x, isn't it? Okay, I'm going to put -3, -3. There's a store button above the on. I'm going to store it for x. -3, I'm storing it for x. This is a calculus way of doing a quick calculation, and if you're only going to use it once. And then I'm going to type in the equation, -x cubed, -x cubed, -x caret 3, minus x squared, plus 3. And it gives me the answer. The TI does order of operations. A lot of people drop the negatives. That's fine. That is one way you can do it. You can type it in as is, straight up, no strings attached. Store it for the variable. Okay? Another way you can do it, this is a really cool way of doing it, because this is like function notation. Very exciting, very exciting, very exciting. I can type this in as the rule. Remember, f of x is the same as y, isn't it? So I'm going to type this in, -x cubed. You do this if you have more than one thing to do. -x caret 3 minus x squared plus 3. See, I had that typed in for my f of x, correct? This is really cool, really bizarre. I like this a lot. I'm going to go to vars. Those of you that don't remember things well, you might want to jot this down. Vars, y bars, function, y1. Vars, y bars, function, y1. And watch this, parentheses, -3. It took -3, put it into the rule at y1 in another screen, and gave me the answer 21. Yeah?
What if you put in y1 and still brought out the reference?
I don't know.
I still got something else.
Great. Yes, Joe? What was what? Oh, I went to vars, y bars, then function. Oh, I don't know if the 82s do. Okay, I think you just use y1 and then the number. Okay. So anyway, the cool thing about this is I can quick copy. You know how like when you text, you quick copy? I don't do that, but I know you can. In fact, a girl this summer at Parkland says, I want a quick copy of my TI. It took me a while to figure out what she meant. You can scroll back to the last 20 to 25 entries on a TI. If I think you've been doing something inappropriate, I'll just say, give me your calculator. And I'll start scrolling back to see what you've been up to. It's a history. I love that. I've given detentions for histories before. You know, some kids type something inappropriate, thinking it's gone forever when you hit clear. It's not, just like the internet. It's never gone. It's always there. So I can go to second and enter, and look, there it is, my last entry. I can scroll back as far as I want, and I'm going to change this to a 0. Delete. And look, I get the answer to the next question, which is 3. I'm going to change it again. I'm going to go to second and enter. And what am I going to put in place of a 0 now? I'll put it in a 2. And there it gives me all 3 questions. Somebody goes, well, what about, doing mental math, all that stuff? Look, there's been a time and a place for that, and we've had that. You need to know how the function notation works on the TI because you'll be asked to do it. So there, look at that, nice and neat, crisp and clear, no problems, moving on. I like that. Very efficient.
What if it doesn't do?
I showed you how you can do the store for x, right?
Yeah.
Well, you can do that. Go back and quick copy that. Put in -3, store for x, right? Then go back, second and enter, second and enter, second and enter, second and enter, second and enter. There it is. Booyah, you get 21. Then change the -3 to 0. 0, store for x. Got it? Second and enter, and get your answer of 3. You can quick copy expressions, you can quick copy numbers, anything you want. Just scroll back, grab it, and put another number in. Huh? I don't know. Yep. Right. I typed it in on that window. I did the problem 2 ways. One, I typed everything on the home screen first and did it. Second, I went to Y1 and typed everything in there and did it that way. So I did the problem 2 different ways on the calculator. They don't go together. They're 2 separate ways of doing it. Mm-hmm. Yeah. Yeah. Well, I went to vars, y vars, function, y1. Okay. All right. So that's pretty nice and slick. I like that. Moving on. What the heck does all this stuff mean? G of 1 over A. What does that mean? That means I put 1 over A in for what? X. So that means G of 1 over A equals 1 over A for all the X's. 1 over A plus 1. You've seen this move several times. This says you put 1 over A in for all the X's. I did that. I put 1 over A in for this X. I put 1 over A in for this X. I put 1 over A in for that X. And now you have to simplify it. Oh my gosh. G of 1 over A equals 1 over A squared, 1 over A plus 1. What move am I going to pull next? What do you think? Does anybody have a thought? What move do I normally sledge it out. If I have a fraction over a fraction, I sledge out the denominators. I'll multiply the top and the bottom by what number? A squared over A squared. If you don't know that move by now, you haven't been paying attention. That's a sweet move. It gets you out of a lot of trouble. I think I've showed you that move once a week for like 6 weeks now. Multiply this through, that gives me a 1. 1 over A times A squared is A, plus A squared times 1 is A squared, and that's your answer. That's what G of 1 over A is. Nice. Just sledge it out. It's going to keep coming up over and over and over. If you say you can't get it, then you got to keep trying until you do. Or come up with your own way of doing it. The next part of this problem said, what is 1 over G of A? What does that mean? 1 over G of A. What am I putting in for the X's? No, I'm not putting in 1 over G of A. What am I putting in for the X's? A. I'm putting A in for the X's. Oh, let me get it green. I'm putting A in for the X's. Then what am I doing? I'm putting 1 over everything. It's a 2-step process. Oh, this is great. So, G of A equals, let's see, A over, is it A squared? Yeah, A squared over A plus 1. A squared over A plus 1. That's the G of A part. The 1 over part, nice. No, you can't leave it like that. That looks confusing. You have a fraction within a fraction. How do you get rid of that? You can sledge it out. That's one way. What else can you do? What? Negative exponents, you could do that. What's the long division bar mean? No, it means divide. 1 divided by A squared over A plus 1. How can you rewrite that? Right, you multiply by the reciprocal. So it's A plus 1 over A squared. I probably wouldn't sledge that out because I've only got one denominator. I'd probably invoke the reciprocal rule. You can divide by a fraction. You can multiply by its reciprocal. Okay? Fantastic. Because the direction said, use this function, g of x, to rewrite these expressions. The first one had 1 over a in parentheses. The second one had the 1 outside the parentheses and the a in the parentheses. Look what's coming up next. G of the square root of a. Nice. Let's get to it. No sense of waiting around. So what is G of the square root of a? I don't know. G of the square root of a. Well, that's easy. You put the square root of a in and you work it out. Uh-oh. This one has its own unique characteristic. How do you rationalize the denominator? Yeah?
Multiply it by its,
Yeah, you multiply by the conjugate. Yeah, that's fantastic. So I have G to the square root of a equals a over the square root of a plus 1. And you multiply by the conjugate. Yeah, square root of a minus 1 over square root of a minus 1. Do I want to multiply out the numerator? No, probably not. I'm not worried about the numerator. What am I worried about? The denominator. Can't worry about everything. Can't worry about everyone. Nice. It was. See, a lot of people just need to get going. They just need to get up, get off the couch, go see what life's all about, instead of sitting there waiting to be entertained by a box. Yeah. Last one. The square root of G of A. What am I putting in for X? What am I putting in for X? A. What am I going to do with it after I put in A? Square root. Remember, whenever I take the square root of a fraction, I always think of it as the square root of the numerator, square root of the denominator. That's how I think of the square root of the whole thing. It is almost like it, except you have to do something that's slightly different. You don't multiply by the conjugate. What do you multiply by? The same thing. Square root of a plus 1. Or the square root of a plus 1. That gives you a over the square root of a plus 1 over a plus 1. Don't be slashing. Don't be cutting off any factors because you're adding in the denominator. You can't cut those out. You can't cut those off. So, multiply by the conjugate, and you had to rationalize. You had to do the reciprocal, and you had to take the reciprocal. Those are very important things to know about algebra. What's next? Domain and range. This is number 18 in your textbook. I heard a sigh that usually means they're ready for more. I like that. You ready? What x's are we using in this problem? Matt? Yeah, I'm starting at -4 with a closed dot. That means including, doesn't it? 1, 2, 3, 4. And, keep going. I'm going, yeah, there's -2. Closed dot and open dot. Does that mean closed circle or open circle? Close. Closed. On my domain, it means closed. So I can keep going. And I can keep going this way, can't I? All the way to what? 4. Open or closed? Open. You can tell some people are channel flippers. Like when I started this example, there are 3 people not paying attention. You know how they flip channels? They don't really get into the show. They just kind of like mindlessly flip. Well, when I got to here, they came back. And they're like, what's going on? And then I went to here, and they're like, flipping the channel again. They're back out. Just stay with me for a little while. Maybe good things will happen. So the domain is from -4 to 4. That's the domain. Closed to open. What about the y's? Which y's are we using? Yeah, 2. Right, -1, 2, -3 to -1. Open circle, right? And what else are we using? Oh, close from 1 to 3. 2 different regions. How do you write union? That's how you do it. -3 to -1. Union 1 to 3. I like that interval notation. I can honestly say you're the only students in Central Illinois right now writing your answers like that. I can honestly say that without a doubt. That's exciting. Yeah, like that. You're the only one. You're the only one taking this class right now in this part of the state writing your answers like that. I know these things. That's why I get paid the big money. That's right. That's why I still work at college. The domain of the function has to do with the previous chapter that you worked with. The square root of a number has to be what? What does the number have to be before you can take the square root of it? Positive and real is the result. What else can you take the square root of besides a positive number? No, that'd be imaginary. We're not graphing out imaginaries. Oh, come on. Some of you are going to leave high school. I think you should know this little tidbit of information. You can take the square root of a positive number, or you can take the square root of 0. The square root of 0 is 0, right? So that means this number right here, that's what it is. It's a number. It's a fancy way of writing a number. You don't know what that number is. This number right here has to be greater than or equal to 0. Have you ever solved problems in which you had 8 minus 3x is greater than or equal to 0? And somebody's going to say, I don't know why you do things so hard. I don't. I do them all the same. You're the one resisting change. Close or open circle at 8/3. Closed. Why do you pick 8/3? Because look at it. It's a factor. Why don't you take the 8 over? Then you didn't learn anything in that chapter. We went by factors. We factored everything. 8/3 makes that equal to 0. It can be closed because it says equal to 0. Now on this side, if I put in, on the left side, if I put in negative 10, is it positive or negative? If I put in negative 10, that's a positive region. If I put in 10, is it a positive or negative region? Negative. So I did my test points, negative 10 and 10. Which region do I want for my answer? The positive, and I want 0. I did all those problems the same way, so when they came up the rest of this book, I knew how to solve them. Find the factors, find the regions, match it up. Yeah. Oh, because I wanted the square root. The square root is a function which passes the vertical line test. The square root is only good for numbers that are 0 or positive. I cannot take the square root of a negative number. That's out. Because I'm graphing. So if something's not negative, it's greater than or equal to 0. Now this problem looks like all the other problems I did, and you can handle any problem like it. I still like it when you, oh yeah, I know. You know how many quizzes I graded where people did this, and they got it wrong? I know. I got 65% of the people in 5th hour that when they did this question, they got it wrong because I forgot to flip it. And they all said we're good. This way, you don't ever have to worry about flipping anything. Oh, negative and negative? Yeah. So it'd be positive, right. And they forget to flip the sign. And they go, well, how come that answer's right when I got that? You forgot to flip the negative. You aren't going to have very many problems like this. They're all going to be factors. If you can remember to flip the sign, go for it. But you'll be in the minority that remember. Okay? I have the stats to prove it. 5 minutes? You're not my timer.
No.
He is. Yeah, see, he's going to tell me. He's in good shape. This one. Haley. When you see a rational algebraic function, that's what this is. Because it has a polynomial divided by a polynomial. What's wrong? No! Negative infinity to 8/3 with a bracket. You can do that. Remember left-hand arrow? Dot? Bracket? Woohoo! Kaylee. When you see a rational algebraic function that has a polynomial divided by a polynomial, and you're wanting to find the domain, what are you looking at? See, she's all nervous. What are you looking at? Yeah. Are you looking over here at this thing? No, you're not looking over here. Are you looking at the numerator? Why? Why are you looking at the denominator? You do, or you can use your program. Go to Program, press Enter, press 613 negative 5, see what it tells you. The quadratic, that's a quadratic equation. 6x squared plus 13x minus 5. That's a quadratic. Nice! I have one that says quadratic.
I know, but what is that?
I don't know. I didn't put it in there.
Can I get rid of it somehow?
Well, later, sure.
Okay, anyways.
What does this tell you if you put in 6, 13, and negative 5? There's only one answer? 0.3 repeating is what? 1/3 and negative 5 halves. So that means x cannot equal 1/3 or negative 5 halves. It could be anything else. Does that make sense? That's the efficient way of doing that problem. Okay? You look there because you cannot divide by 0. You cannot divide by 0. We got the quadratic program. We just typed it in and got our answer. So for homework, try to get through 27 odd. On what page are we on? One what? 151. Okay? Fantastic. I hope this worked because I needed this recording in a big bad way. And here we go.